Alright students, so let's take a look at this video on voting theory and specifically insincere voting. So what is insincere voting? Well, first of all, our objectives are we're going to define insincere voting and provide an example of when insincere voting may occur. And we're going to introduce instant runoff voting. So what is that? And we talked a little bit about it already in class. So here we go. Insincere voting in an election, insincere voting, also called tactical voting or strategic voting, occurs when a voter supports a candidate other than his or her sincere preference for a strategic purpose or to prevent an undesirable outcome. This can happen when more than one candidate share somewhat similar points of view, and let's look at an example. So specifically, let's look at this sort of fictitious election for student body president. Candidate A is a Republican, candidate B is a Democrat, and candidate C is an independent. And for this argument, we're going to assume that the Democrat and independent have common points of view. So the independent is, leaning towards the Democrat type views. So if that's the case, we could have some voters in the independent column may choose to vote for the Democrat just so the Republican doesn't win. And so that's what insincere voting means. If they really, really like the independent candidate, but they really don't want the Republican to win, then maybe they'll vote for the Democrat instead. So that's all insincere voting really means. So in this case, using the plurality method, candidate A is clearly the winner, right? They have the most votes. So, and actually the interesting thing here, it's plurality, but they don't have a majority, right? They only have 42% of the vote. So they got 358 of the 850 total for 42%. The Democrat came in second with 32%, and the independent got 25%. So we're going to look at some other voting methods and see if there's another way that could be more fair and to avoid this sort of bias. So let's take a look at this election under the Condor method, right? So we looked at that before. And all this is saying is how do each of the candidates do on a one-to-one basis. So if we look at A versus B, or the Republican versus the Democrat, we eliminate all of the C's. So A beats B here, so the Republicans beat the Democrat there. The Democrat beats the Republican here, but the Democrat also beats the Republican under the independents. So B is preferred over A in that scenario. But when we look at C, the independent votes, and this kind of makes sense if you think about it. And I'll explain in a minute. C beats B here, so they beat the Democrat. They lose to the Democrat in this column, but C beats the Democrat in this column. So actually, C is preferred over B. And the independent, C, is also preferred over A, because A wins here, but C gets all of these other votes. So under Condor C is actually the winner, which if you think about it, right, the Republicans, their second choice is going to be the independent. They don't want to vote for the Democrat. And same with the Democrats. They don't want to vote for the Republicans, so their second choice is going to be the independent. So the independent gets all these second choice votes, and that's why they win the Condor C. So this helps us address insincere voting, because if we think about, we want to mitigate all of that insincere voting of people voting for their second choice to kind of skew the election, what we can do is do an instant runoff. And this is also called plurality with elimination. It's a modification of the plurality method that attempts to address the issue of insincere voting. In IRV, voting is done with preference ballots, and a preference schedule is generated. So you don't just vote for one person. So it's different than a normal election for president or something like that. The choice with the least first place votes is then eliminated from the election, and any votes for that candidate are redistributed to the voter's next choice. This continues until a choice has a majority or over 50% of the vote. So let's look at an example. So again, here's the same set of ballots, and what we're going to try and figure out here is if we eliminate the last place vote which would be this one, right? So we're going to eliminate them because they had the smallest percentage. Then we look at where did these votes go? Well, these votes should go to B because that's what happens. So these 214 votes are going to go up to B. And how this eliminates that insincere voting is because people are going to vote who they want to vote for, and then because they can rank their candidates, because they know if their candidate loses that they're going to get their second choice. So it kind of eliminates that whole insincere voting thing. So here are the results under this method, and you can see 214 plus 278 gives you 58%. So that's the winner. And the weird thing about this election is under plurality method, C was the winner. Under Condor plurality, A was the winner. Under Condor C was the winner. And under this method, then B is the winner. So this actually violates two of the fairness criteria, the plurality criteria and the Condor criteria. So again, elections are not always going to meet all of the fairness criteria, which is what we learned about Arrow's impossibility theorem. So I hope this helps, and please let me know if you have any questions.